Hey everyone, let's chat about section 5.2. It's something called discrete versus continuous domains. We've already talked about domains being the set of all x values. So now let's talk about the two different types of x values that we can have, something called discrete and continuous. So discrete is definitely a word that we haven't talked about before. It's a set of input values, we know that's x, that consists only of certain numbers in an interval. So it's a very clear set of numbers, okay? So for example, what types of variables are discrete? So something could be like the number of tickets would be discrete. So it could be like from 0 to 100. It cannot be negative numbers, and it could not be more than 100 because there might not be enough seats, you know? It cannot be 1.5 because it's a whole ticket. So it's a very specific set of numbers. Number of students. So again, I've got 25 students in a classroom. It's not 2.5 students, and it's not negative numbers. It's a very set number. And the number of textbooks, very similarly. Discrete looks like this. It's just points, right? Because here, check out what my domain is. My domain, we've done this. It's 0, 1, 2, 3, and 4. It's very clear, whole numbers. There's nothing else going on. The range, it is 0, 2, 4, 6, 8 on the y-axis. It's nothing else. This is very set. That's discrete. It's very determined, predetermined already. Continuous sounds more like its name. Continuous. It's a continuing graph. You can think about it going on forever with an arrow. A set of input values that consist of all numbers in an interval. So some examples could be time, right? It could be 60 seconds. It could be 61.5 seconds, right? We could have different times. Weight, you don't automatically, as a kid, you don't automatically go from 5 pounds to 6 pounds. You go 5.1, 5.2, 5. You have to hit all of those other pounds first. Same with temperature and height. What you're going to notice on a graph of a continuous set of data is we've got an arrow. It goes on forever. Or it's got a line. Doesn't have to have the arrow. It's got to have a line. When we write our domain for continuous data, we're writing it with inequalities, with less than or greater than symbols. My domain, let's think about this. Remember, it's x values. Look at our x values. The smallest x value is 0. And then it goes to 1, 2, 3, 4, 5. It goes forever. So our domain is x has to be greater than or equal to, because this is a point, 0. It's never going to be negative because it starts here. My range is going to be the same exact thing. Look where it starts here, and then it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It goes up. So we're going to practice writing this and determining whether we've got discrete or continuous data. As soon as I see points, or guess what, dots, I know this is discrete. When I write my domain for discrete, it's like we practiced in 5.1. I'm just listing the x values. 0, 1, 2, 3, 4, 5, 6. If you're not sure how I got these numbers, go back and watch 5.1 video. My range, 0, 1, 2, 3, 4, 5, 6, using these points, these x values and these y values. Notice for B, it's very similar. I've got points. Dots are discrete. Listed the domain, listed the range in the curly brackets. Let's talk about these now, guys. Notice C has a line. It's everything from this point to this point. That makes it continuous. I don't see dots. My domain is my x values. Look at the x value this graph starts on. Think about domain being left to right. The furthest left is -1, -2, -3 is -4. Put the line here. It goes from -4, that's a closed circle, so I'm going to have less than or equal to x because it's domain, which is less than or equal to what is the right. The furthest to the right is 2. So the x values go between -4 and 2. My range I want you to think about bottom to the top. The bottom of this graph is at -1, which is less than or equal to, because it's a closed circle, the y values, because I'm talking about range, which is less than or equal to the top 1, 2, 3, 4. Okay, let's look at this one, the domain. Left to right. The furthest to the left, this graph is an open circle on -3, and the furthest to the right on the x-axis is a 1, closed circle on 1. Range is bottom to top. Bottom of the graph is at -4, closed circle. Top of the graph is at the y value of 0, or equal to, because of this right here, that's closed, so I have to close it. And then I've got a couple more examples. Let's talk about this one. I see this line, so it's continuous. Domain furthest from the left is -3, less than or equal to because it's closed. Furthest to the right, the x value is a 2. Range is the bottom of the graph is -5. To the top of the graph is a 4. Think about boxing this in. Okay, left to right, bottom to top. This one, again, left to right, I've got this arrow, so I'm not going to have an and statement. I say x is greater than or equal to 0 because all of these x values are greater than or equal to 0. My range, the y values, are all greater than or equal to -2. Notice if we have, just look at G here, it goes on forever, so I've got continuous. There's this curve here. The domain, because it's going to go out and upwards forever, is all real numbers. Goes outwards forever. I know it looks like it's going up, but it continues to go outwards. The range, what's the bottom of the graph? The bottom of the graph is at -6, so y has to, and then it goes up, right? Has to be greater than or equal to -6. And then next, if you see on H, it goes on forever, and I've got a continuous graph. It covers all of our x values, and then it covers all of the y values, our domain and our range. This symbol right here means all real numbers. You do like an R over 2 straight lines. Okay, so that's 5.2, talking about discrete and continuous graphs and data. Good job, guys.